Welcome to CognitionChunks. This information is for entertainment only. Note these backgrounds are artistic, not realistic. I am not an astronomer. Is this useful? Is this nonsense? Join me as I attempt to learn from GPT. Here is GPT Explains the Galaxies. Episode 8. Spiral Galaxies and Barred Spiral Galaxies. Spiral galaxies are characterized by their distinct, flat, disc-like structures with spiral arms winding out from the center, often hosting a significant amount of star formation, dust, and gas. The Hubble classification further divides spiral galaxies into three subcategories, SA, SB, and SC, based on the tightness of their spiral arms and the size of their central bulge. Similarly, barred spiral galaxies, which feature a central bar-shaped structure from which the spiral arms emerge, are classified as SBA, SBB, and SBC, paralleling the classification of regular spirals.
Spirale galaxie, SA, SB, SC.
SA galaxies. These galaxies possess tightly wound spiral arms and a relatively large and prominent central bulge. The disks of SA galaxies contain less dust and gas compared to the more loosely wound spirals, and they tend to have a more significant population of older, redder stars. The spiral arms are less defined and more clumpy, due to the lower rate of star formation. SB galaxies. SB galaxies offer a balance between SA and SC types, with moderately wound spiral arms and a medium-sized bulge. They exhibit more prominent spiral patterns than SA galaxies and have more gas and dust, facilitating active star formation within their arms. SC galaxies. Characterized by their loosely wound, well-defined spiral arms and a small central bulge, SC galaxies are rich in gas and dust, making them fertile grounds for active and ongoing star formation. The arms of SC galaxies are often populated with young, hot, blue stars, giving them a very vibrant appearance. Barred spiral galaxies. SBA, SBB, SBC. Barred spiral galaxies share many characteristics with their spiral counterparts, but are distinguished by a central bar structure that spans the core and extends into the disk, from which the spiral arms emerge. SBA galaxies. These galaxies have a prominent central bar and a large bulge, similar to SA spirals in terms of bulge size. The spiral arms extending from the ends of the bar are tightly wound and contain relatively less dust and gas. Star formation in the arms of SBA galaxies is less pronounced than in more loosely wound barred spirals. SBB galaxies. Featuring a bar that is less prominent than in SBA galaxies, SBB types have moderately wound spiral arms that emanate from the ends of the bar. These galaxies have a noticeable amount of dust and gas in their arms, leading to active star formation, though not as extensive as in SBC galaxies. SBC galaxies. The bars in SBC galaxies are less prominent, and the spiral arms are very loosely wound and clearly defined, starting from the ends of the bar. These galaxies are abundant in gas and dust, hosting significant regions of active star formation, and have the smallest bulges among the barred spirals. Formation and evolution. Spiral galaxies are believed to form and maintain their spiral structures through a combination of rotation and density wave theory, where spiral arms represent regions of higher density that rotate at a different speed than the galaxy's stars and gas. The presence of a bar in barred spirals is thought to be a dynamic feature that can evolve over time, influencing the movement of gas within the galaxy and potentially driving star formation in the central regions and along the spiral arms. Role in the universe. Spiral and barred spiral galaxies are significant sites of star formation in the universe, contributing to the ongoing process of stellar evolution and chemical enrichment of the interstellar medium. They are typically found in less dense regions of the universe, such as the field and the outskirts of galaxy clusters, and their detailed structures provide crucial insights into the processes of galactic dynamics and evolution. Conclusion. Spiral and barred spiral galaxies, with their stunning and varied structures, are among the most visually striking objects in the universe. Their classification from SA/SBA to SC/SBC reflects a continuum in spiral arm tightness, bulge size, and star formation activity, offering a window into the diverse ways in which galaxies can form, evolve, and contribute to the cosmic tapestry. Thank you for joining us for another Cognition Chunks. Please like and subscribe.